This world is shaped inward, a single vast basin sloping gently toward its center where violet sand never quite comes to rest and a lake of glass-like liquid holds perfectly still. The air is thin here, carrying sound in unfamiliar ways. Quiet things travel, louder ones don't. Nothing rushes on this planet. Change happens slowly, guided by gravity, temperature, and time. What gathers here does so because it can remain, and what remains begins to shape the basin in return. Out here, the system is quiet in the way that makes you check your instruments twice. The star is smaller than the ones most people picture first. Not tiny, not dim, just modest, a steady pale gold sun that doesn't throw tantrums. Its light spreads cleanly through a thin scatter of dust, and you can see the architecture of the system without much glare. A few inner bodies pulled close, a broad lane of grit and stone farther out, and then the cold dark where the light fades into background static. The Whispered Basin sits a little farther than the sweet spot, where water would normally behave the way you're used to. Not so far that everything is locked in ice, but far enough that surface warmth is a daily negotiation between sunlight, terrain, and whatever the atmosphere can manage to hold on to. Two other planets share the neighborhood in any meaningful sense. An inner world that's darker and heavier, with a tight orbit and a faint metallic sheen when it catches the sun, and an outer one that's pale, low contrast and wide-swinging, a place that looks like it never fully decided whether it wanted to be rock or ice. This planet doesn't compete for attention with color. No big swirls, no dramatic storms from orbit. Just a broad, shallow palette. Muted purples and greyed violets where sand dominates, darker bruised tones where rock breaks through, and a faint suggestion of something glassy near the center. A highlight that stays in the same place, not flashing, not rippling, just sitting there like a held note. Even from this distance, the shape is the first thing you register. Most planets read like spheres with texture. This one reads like a sphere that's been pressed inward. A world-sized depression, smooth in its curve, taking up a huge portion of the surface. Not a neat crater with a rim, but a basin so large it feels like the planet has been sculpted into a bowl. The edge of the basin is high ground by default, a ring of uplands that wraps around the depression like a slow shoreline. Beyond that rim, the rest of the planet exists, but your attention keeps getting pulled back to the sink of it, the center of it, the geometry that dominates the globe. As you close in, the star's light starts to reveal subtler things. The basin isn't empty. It's active in a slow way. The violet sand isn't flat and settled. It's constantly slipping downhill, always migrating toward the center, and that movement draws faint lines across the slopes. Long drifts, scalloped ridges, soft channels where repeated avalanches have carved the same path over and over. The sand looks fine-grained, almost powdery from orbit, the kind of material that doesn't pile sharply unless something makes it. And something does. Gravity here is a touch lighter than Earth normal. Not enough to make you float, but enough that falls take a fraction longer, and moving heavy loads would feel slightly less punishing. That small change matters over geologic time. It means grains tumble differently. It means slopes can hold at angles they wouldn't elsewhere, then let go in long, lazy slides that don't explode into dust the same way. It means the basin's walls can remain steep without collapsing into chaos, because the sand is always moving, always redistributing, like a conveyor belt with no motor, just the patient pull toward the lowest point. The atmosphere is present, but barely. Up high, it doesn't have the thick, comforting haze you get with a dense sky. There's very little to scatter light. That's why the planet looked so crisp from space. The sky, what there is of it, doesn't bloom around the horizon. It doesn't soften edges. It doesn't hide distance. You can see far because there's not much air getting in the way. But thin doesn't mean simple. As you begin entry, the first thing you notice isn't turbulence. It's how quickly the temperature can shift when you cross layers. The upper atmosphere is cold, dry, and stingy with drag. There's a point where the air thickens just enough to start mattering, not thick like a blanket, more like the first hint of resistance against motion. The physics changes in steps, not a smooth ramp. That suggests stratification. A light gas mix overall, but with bands of slightly denser composition caught in the basin's vast circulation patterns. The planet rotates slowly, not tidally locked, but not spinning fast either. That gives weather systems time to stretch out and settle into predictable paths. With a giant depression dominating the surface, the basin becomes the main engine for air movement. Daytime warming along the rim, nighttime cooling in the center. Constant, gentle exchange between high ground and low. Even without much air to work with, the size of the structure forces patterns to exist. Lower down, the color of the sand changes under you. From orbit, it's violet. Up close, it becomes a spectrum. Lavender dust in some areas, deeper purple grains in others, and occasional black flecks that catch light sharply. Mineral fragments, glassy shards, maybe bits of basalt broken down over time and carried downhill until they find a resting place. The basin walls are not uniform. Some sections show exposed rock like bones through thin skin. In places you see long, dark seams where the sand has peeled away in recent slides, revealing something harder underneath. In other places, the sand is thick, draped across the slope in soft blankets with rippled textures like slow water frozen in motion. And then there's the center. The lake is real. The highlight from orbit wasn't a trick of light. It sits at the deepest point like a lens laid into the planet. Not water, not ice. A surface that reflects in a way liquid should, but it doesn't move. No wind-driven texture, no visible waves, no ripples that track across it as the air shifts. It's smooth enough to look artificial, but the surrounding geology argues against anything built. This is a natural stillness, the kind that comes from the material itself. Liquid glass is the closest description, but it doesn't mean molten. It means a substance with a glass-like refractive quality while remaining fluid at local temperatures. Maybe a silica-rich melt with unusual chemistry, maybe a supercooled solution that behaves nothing like water, maybe a metallic glass-forming liquid that refuses to crystallize under the conditions here. Whatever it is, the lack of surface disturbance tells you something important. Either the atmosphere is too weak to push it, or the liquid is too viscous to respond, or both. Now the air becomes more than a technical detail. It becomes a presence. Thin air changes sound. On a world like this, silence isn't just quiet, it's mechanical. With fewer molecules to carry pressure waves, sound transmission weakens. But the Whispered Basin does something stranger than everything is muted. Here, the air carries sound selectively. It's the first local paradox you learn to respect. A whisper can travel while a shout dies young. That isn't poetry. It's a set of conditions. Loud noises aren't just louder whispers. They're shocky, turbulent, messy pressure fronts. In thin air, those fronts can break apart, distort, and lose coherence fast, especially if the atmosphere is layered and shearing, especially if there are temperature gradients that refract sound unpredictably. A whisper, by comparison, is a cleaner signal. Small amplitude, steadier wave pattern, less likely to trigger the non-linear behavior that causes rapid scattering. On top of that, the basin's geometry matters. A bowl shape is an acoustic tool. It reflects, it channels, it focuses and refracts, depending on the slope angle and the hardness of the surface. If the basin floor and walls are covered in fine sand, that sand should absorb sound, but absorption depends on frequency. Fine grains can swallow some frequencies and let others skate across. If the air is dry and thin, higher frequencies can die faster, while certain low, gentle bands can travel farther. If there are temperature inversions hugging the basin floor, sound can bend along layers rather than escaping upward. So when you say whispers travel miles, What you're really saying is, the basin is built to guide the smallest, softest signals along a path, while the big violent ones get shredded by the sky. As you drop lower, you start to see why the sand never fully settles. It isn't just gravity. There are constant micro-movements, subtle slumps, tiny collapses, long, slow avalanches that can take minutes or hours rather than seconds. The sand behaves like a living surface, not because it's alive, but because the whole basin is always slightly out of balance. A small change in temperature can loosen a layer. A faint tremor can start a slide. A pressure shift can move grains along a ridge. And because the basin is so large, those little movements are happening somewhere all the time. You see it as drifting curtains of dust down the slopes. Not storms, there's not enough air, but low, slow sheets of falling grains, like the planet is constantly combing itself toward the center. Above the basin rim, the land is harsher. The higher ground gets more direct sunlight and more extreme temperature swings. The thin atmosphere can't smooth out day-to-night changes. Rock up there expands and contracts, fractures and sheds. That debris breaks down and eventually joins the flow downhill. The rim looks like a broken crown, ridge lines, mesas, scarps, and long dry valleys that point inward as if everything is being pulled toward the basin by design. The sky overhead, even this low, isn't a familiar blue. It's pale, slightly lilac-tinted, like the sunlight is being filtered through trace gases that preferentially scatter the shorter wavelengths. There's a clarity to it that feels almost sharp. Stars would show early here, the sun would set and the sky would go dark quickly without a long twilight. And when the basin is in shadow, it won't be cooler. It will be cold enough to change the behavior of the sand, cold enough to thicken any viscous liquids, cold enough to create a daily rhythm of tightening and loosening across the slopes. The lake remains the most unsettling feature because it refuses to participate. A normal liquid announces itself. It moves, it responds, it shows you wind and vibration and temperature in its skin. This one just sits there, a mirror at the bottom of a world. When you come in at an angle, it reflects the basin walls in a warped, perfect way. The reflection is so clean you can pick out the banding on the slopes. And when the sun is high enough, the lake throws light back upward, a cold gleam that paints the underside of overhangs and turns the lower basin into a place with two sources of illumination: direct sunlight and reflected glasslight. You begin to understand why this world earned its name without needing folklore. Not because it feels like whispers, because it behaves like whispers, because the physics favors the smallest voices. Down here, anything that does make sound becomes meaningful in a way it wouldn't elsewhere. Footfalls, shifting tools, a breath, fabric brushing against itself, all of it has the potential to carry, depending on where you stand, which slope you face, which layer of air you're in. And louder sounds, the ones you'd normally use to test distance, to call out, to signal safety, those might just vanish into the thinness like they were never made. That flips instincts upside down. It makes you careful without having to scare you. It forces you to listen in a different way and to speak in a different way. Not for drama, for practicality. Near the lower basin, the sand texture changes again. It becomes smoother, more uniform, as if the constant avalanches have sorted the grains. Fine dust collects in shallower grades. Heavier fragments settle in subtle arcs like river deposits, except there's no river, just slope and time. In a few places you can see faint crusting where minerals have precipitated out of trace moisture or out of the air itself, binding the top layer into a delicate skin that cracks when disturbed. And still, no obvious signs of biology yet. No green, no visible mats, no clustered dark patches that scream colonies. The environment is harsh for anything that relies on abundant air or liquid water. But harsh doesn't equal dead. It just means if life exists here, it's either small, slow, protected, or so chemically different that you won't recognize it at first glance. The basin is big enough to create microclimates, though. Even in thin air, low points can trap heavier gases overnight. Cold air drains downhill. Dust collects. If there's any volatile cycling, sublimation, condensation, seasonal deposits, it'll happen in the center and along shaded sections of the slopes. If anything living has found a foothold, it would likely be where conditions are least violent. Places with stable temperatures, sheltered hollows, mineral-rich dust, and a reliable schedule of gentle atmospheric movement. The first stage of arrival ends with a simple realization. Everything here points inward. Terrain, debris, temperature gradients, airflow, even light. All of it ends up focused toward the bottom of the bowl. The Whispered Basin isn't just a landscape feature, it's the planet's main event. The rest of the world feeds it, and the center holds something that behaves like a liquid but refuses to move. From here, the details start to matter. What the sand is made of, what the air is made of, why whispers travel, why loud sounds collapse, and what that glass lake actually does when you get close enough to see more than its reflection. As attention settles deeper into the basin, the scale starts to recalibrate how distance feels. What looked smooth from above breaks into gradients and thresholds. The slope isn't continuous in the way a simple bowl would be. It's stepped. Not sharply, not like terraces cut with intent, but in long, shallow bands where material has accumulated, stalled, then given way again over time. Each band marks a balance point between gravity, grain size, and whatever subtle forces move through the ground beneath. Those forces aren't dramatic. There's no constant seismic chatter. Instead, there's a slow internal shifting, the kind that doesn't register as an event, only as change noticed later. A ridge that wasn't there before, a channel that's widened, a surface that sounds different under contact than it did yesterday. The sand here isn't uniform once you stop thinking of it as sand. Some grains are angular, fractured from harder parent rock. Others are rounded and dulled, worn smooth by long descent and repeated contact. Mixed in are translucent particles that catch light differently, pale, almost milky flecks that glow faintly when the sun hits them at low angles. Those aren't reflective in the same way the glass lake is. They don't mirror. They scatter. When enough of them collect together, the ground takes on a soft internal brightness, like light trapped just below the surface. That glow isn't constant. It shifts with time of day, angle of illumination, and depth of the layer. In shadow, those same areas look dead and matte. In low sun, they come alive again. It gives the basin a subtle pulse, not because anything is moving quickly, but because light is being revealed and hidden as the planet turns. The air close to the ground behaves differently than it does higher up. You start to notice it in how dust settles. A disturbed patch doesn't bloom upward and drift away. It lifts just a little, then slides laterally, hugging the slope as if it's following an invisible contour. That tells you the lowest layer of atmosphere is denser than the air above it, not by much, but enough to matter. Overnight cooling likely causes heavier gases to pool in the basin, creating a shallow, slow-moving blanket that creeps along the terrain. That layer is part of why sound does what it does. Within it, gentle vibrations can travel far, guided by the curvature of the basin and refracted by temperature differences between sunlit and shaded ground. Step outside it, raise the source of sound, increase its force, and the signal scatters upward into thinner air where it breaks apart. You don't experience this as echo. There are no dramatic returns, no repeating calls bouncing back at you. Instead, there's a sense of reach, a feeling that quiet sounds don't fade the way they should. They thin out, stretch, become harder to locate, but they don't vanish quickly. The ground itself contributes. The fine sand absorbs sharp impacts but transmits low-frequency vibrations well. A soft footstep compresses grains rather than striking them, producing a signal that travels along the surface instead of exploding into the air. It's less about loudness and more about shape. The basin rewards smooth, continuous input and punishes sudden force. Closer to the center, the slope eases, the avalanche is slow. Material that has traveled for years finally comes to rest, at least temporarily. This creates a broad apron around the lake, not flat but calm compared to the walls above. Here the sand is deepest, layered in thin sheets like pages laid one on top of another. Each sheet records a different episode, a season of heavier shedding, a period of thermal cracking up on the rim, a time when the wind, weak as it is, had slightly more say. In some places those layers are exposed by shallow cuts, revealing banding that looks almost deliberate. Dark, light, repeating in irregular rhythm. You could read history here if you knew how to interpret it. Orbital variations, axial tilt cycles, long-term changes in atmospheric composition. The planet doesn't hide its past, it just writes it slowly. The lake's edge is sharper than expected. There isn't a gradual shoreline where sand blends into liquid. The boundary is clean, sand stops, liquid begins. No visible wetting, no creeping fingers of fluid climbing the grains. The material in the lake doesn't soak, it doesn't cling. It simply occupies its space and refuses to interact beyond that. At very close range, the surface reveals a faint internal movement. Not waves, but slow, deep currents beneath the skin. The top layer remains smooth because whatever motion exists below doesn't translate upward. It's as if the surface tension is unusually strong, or the viscosity gradient changes with depth. Light entering the lake doesn't behave simply either. Some of it reflects cleanly, throwing sharp images back. Some of it sinks in and vanishes, and some refracts in unexpected ways, bending enough to illuminate the underside of the basin rim in places that direct sunlight never reaches. The lake acts like a lens as much as a mirror, redistributing energy quietly. That redistribution affects temperature locally. Areas near the lake's edge experience smaller day-night swings than the slopes above. Heat absorbed during the day is slowly released back into the basin after sunset. Cold from the night lingers longer into the morning. This makes the center the most thermally stable region on the planet's surface. Stability invites complexity. If anything here has learned to persist, this is where it would anchor itself. So far, there's still nothing obvious. No movement against the sand, no patterned growth, no clustered discoloration that screams biological origin. But there are hints that chemistry is doing more than sitting idle. Along the boundary between sand and glass, thin films sometimes form. Not continuous, not permanent. Just brief sheens that appear at certain temperatures, then fade again. They could be condensates, trace gases settling out overnight, reacting with minerals at the interface, then sublimating once the sun returns. Or they could be residues from reactions within the lake itself, precipitating upward when internal currents bring different layers into contact. Whatever the cause, the effect is subtle. Nothing froths. Nothing spreads. It's chemistry behaving politely. Farther out from the lake, the sand occasionally crusts over in irregular patches. These crusts are fragile. Step on one and it collapses into powder. But while they last, they slightly alter how heat and sound move across the surface. A crusted area reflects more light, warms less during the day, cools more slowly at night. It also transmits vibration differently, creating faint acoustic shadows where whispers bend around rather than pass straight through. That matters if you're trying to understand how information moves here. The basin doesn't amplify sound evenly, it routes it. Certain paths carry signals farther than others. Certain slopes act like dead zones where even soft noises fade quickly. Over time, these patterns shift as the sand moves, as crusts form and break, as temperature profiles change. There is no fixed acoustic map, only tendencies. Above all of this, the sky remains spare. Clouds don't really form the way you'd expect. There's not enough moisture, and the air column is too thin. What you get instead are occasional high-altitude hazes, transient veils that catch sunlight and tint it briefly before dispersing. When they pass overhead, the light softens just enough to blur shadows, and the basin seems to relax for a while, as if the world prefers gentler illumination. Night comes quickly. Without a thick atmosphere to hold heat or scatter light, sunset is abrupt. The sun drops behind the rim, and the basin floor cools fast. The sand contracts. Microfractures open and close. Tiny shifts ripple outward from countless points. You don't hear this as noise. You sense it as a change in how sound would behave if it were made. Stars appear in numbers that feel excessive. The sky fills all at once, sharp and unmoving. Reflections double them in the lake, creating the illusion of depth below the surface as well as above it. The basin becomes a place suspended between two star fields, with only a thin layer of sand and air marking the boundary. If there is life here, it would need to tolerate silence and cold, stability and slow change. It would need to use energy carefully, hide from extremes, and possibly communicate in ways that don't rely on force. It would need to be patient. For now, the basin offers no confirmation, only conditions. Time behaves differently in the basin, not because it moves slower, but because fewer things demand attention at once. There are no fast cycles here, no storms racing across the surface, no tides pulling at the ground. Change arrives as accumulation, grain by grain, degree by degree. Once you stop expecting motion, you start noticing patterns that only reveal themselves when nothing is trying to distract you. One of the first of those patterns shows up at the margins of the apron surrounding the lake. This is where the sand finally hesitates, where downhill becomes almost level and the constant pull toward the center weakens just enough for sorting to happen. Heavier particles settle sooner, lighter ones drift farther. Over long spans, this creates zones, not visible at a glance, but obvious once you spend time with them. A step to the left and the sand sounds different under pressure. A step forward and the color shifts by half a shade. A step back and the surface firms slightly, as if a hidden layer is closer to the top. Those hidden layers matter. Beneath the loose surface lies a compacted stratum formed by repeated burial and compression. It isn't solid rock, but it isn't free-flowing either. It behaves like a memory foam of mineral grains, yielding slowly and returning just as slowly. When pressure is applied, it redistributes rather than resisting outright. That property dampens vibrations, but it also carries them, spreading energy outward in smooth, low-amplitude waves. This is another reason whispers travel. Sound here isn't only airborne, it couples into the ground, especially at low force. A quiet voice, a gentle scrape, a slow movement transfers energy into the sand without breaking its structure. That energy then migrates laterally along the compacted layer, re-emerging as faint pressure changes in the air farther away. Loud sounds, by contrast, fracture the top layer, scattering energy vertically and killing its range. The basin doesn't like being startled. Temperature mapping reveals further complexity. During the long day, the upper slopes heat unevenly. Darker mineral bands absorb more energy. Lighter areas reflect it. The result is a mosaic of microthermals that feed into downslope air movement. Warm air creeps downward in thin sheets, while cooler air drains into hollows. None of it moves fast, but it's constant. At night, the pattern reverses. The basin floor becomes a cold sink. Air slides inward and settles. By morning, the lowest point holds the densest air the planet can manage. That nightly pooling may only be a few meters thick, but in an atmosphere this thin, that's enough to change everything. Within that layer, trace gases concentrate. Compounds that would be insignificant higher up reach levels that allow chemistry to proceed. Reactions that are impossible elsewhere become feasible here, quietly, without fanfare. The basin floor is less about abundance and more about permission, a narrow window where certain processes are allowed to happen at all. It's in these conditions that the first unambiguous anomalies appear. They aren't moving. They aren't obvious. and they don't announce themselves as life. Scattered across parts of the apron are patches where the sand behaves differently under repeated temperature cycling. These areas warm more slowly in the morning and retain heat longer after sunset. Their boundaries are irregular but persistent. They don't migrate with the rest of the sand. Avalanches flow around them rather than through them, as if the grains there are slightly bound. Closer inspection shows that they are. The grains in these patches are coated in a thin, translucent film, not thick enough to bridge gaps entirely, but enough to alter friction. The coating appears to be organic in structure, mineral in origin. Long-chain molecules assembled from simple precursors, stabilized by the basin's consistent thermal rhythm and the presence of specific trace elements leached from deeper layers. This isn't life in the way you'd instinctively define it. There's no metabolism, no growth, no reproduction in the usual sense. But the films persist, and they modify their environment in ways that increase that persistence. They reduce erosion locally. They stabilize temperature slightly. They trap fine dust that brings in new raw material. Over time, patches expand at the margins, not by spreading actively, but by making nearby conditions more favorable for the same chemistry to occur again. If you're looking for intent, you won't find it. If you're looking for inevitability, it's everywhere. These patches are most common near the lake, where thermal stability is highest and nightly gas pooling is most reliable. But they also appear in sheltered pockets along the lower slopes, places where the basin's geometry creates local calm. Over decades, centuries, longer, these patches could coalesce. They could form continuous networks across certain elevation bands, subtly reshaping how sand moves and how sound travels. Already they create acoustic quirks. A whisper passing over one of these stabilized zones travels farther and more cleanly than over bare sand. The film smooths out high-frequency scattering, allowing pressure waves to retain coherence longer. The basin's reputation for carrying quiet sounds isn't uniform. It's enhanced by these chemically altered surfaces, even though no one would notice them without careful study. The lake interacts with these processes too. Its internal currents aren't random. They follow slow, repeating paths influenced by the planet's rotation and the basin's shape. Over long periods, the lake releases vapors, not enough to form clouds, but enough to contribute to the nightly pooling layer. Some of those vapors condense at the sand-liquid boundary, adding new compounds to the mix. Others drift farther before settling, seeding the slopes with the ingredients needed for the surface films to form. The lake is not alive, but it participates. There are moments at certain sun angles when the lake's surface reveals faint structures beneath, not shapes but gradients, zones of slightly different refractive index moving past one another at glacial speeds. These are likely compositional layers, maintained by the balance between heat input from above and whatever residual heat the planet retains below. The lake is deep, far deeper than its placid surface suggests, and its behavior hints at complexity that doesn't announce itself. Sound behaves strangely near the water. Even quiet noises made close to the surface tend to vanish rather than travel. It's as if the lake absorbs vibration, pulling energy downward instead of letting it skim outward. The boundary acts as a sink for acoustic energy, further reinforcing the basin's pattern. The center gathers not just sand and air, but also disturbance. That makes the perimeter zones more active acoustically than the center itself. Whispers spoken near the lake might not travel far at all, while the same whisper made a little higher up the slope could carry for kilometers along the curve of the basin. The planet teaches you its rules slowly. It doesn't punish mistakes loudly. It just fails to respond the way you expect. A shout goes nowhere. A careful movement resonates. A forceful action leaves no trace. A gentle one changes things over time. Night deepens again, and the basin settles into its most stable state. The surface films contract slightly in the cold, tightening their grip on the grains beneath. Gas concentrations peak. The lake releases stored heat in a slow exhale that keeps the center from dropping as low as the rim. Stars reflect cleanly off the glass, creating a false sky below your feet. If intelligence were to arise here, it wouldn't be quick or expressive. It wouldn't announce itself with structures or signals. It would be something that listens first, acts second, and never wastes energy on being seen. Whether the Whispered Basin ever reaches that point remains an open question. For now, it is a world where chemistry edges toward organization, where physics favors subtlety, and where the quietest inputs travel the farthest. The basin continues to collect. With repeated cycles, the basin starts to reveal long-term behavior, the kind that only becomes obvious when nothing dramatic interrupts it. The surface films don't remain static. They don't spread evenly, and they don't simply accumulate. They respond to gradients. Temperature first, then chemistry, then sound and vibration, in ways that are indirect but consistent. Over long spans, this creates a patchwork that looks random until you stop expecting symmetry. The most stable films form where three conditions overlap: shallow slope, reliable nightly gas pooling, and consistent low-level vibration. That last condition isn't intuitive, but it matters. The basin is never completely still. Even in the absence of seismic activity, thermal contraction and expansion create minute stresses that ripple through the compacted subsurface layer. Where those ripples pass regularly, they prevent stagnation, keeping reactants mixed and preventing the films from becoming brittle. In places where the ground is too quiet, the films fail. They crack, flake, and are eventually eroded away by the next slow avalanche. In places where vibration is excessive, near active fracture lines or zones of frequent slumping, the films never get a foothold. Stability here isn't about absence of motion, it's about moderation. That principle repeats across the basin in different forms. The sand itself becomes more sorted over time, not just by size but by composition. Certain minerals migrate towards specific elevations because of how they interact with heat and air. Darker grains settle slightly higher up the slopes where they absorb more sunlight and increase local thermal gradients. Lighter, more reflective grains drift farther down, cooling the lower basin and reinforcing the nightly pooling effect. The result is feedback, but not runaway feedback. Everything here corrects gently. No process dominates for long. If one region becomes too warm, it sheds energy faster at night. If another becomes too stable, it starves itself of the minor disturbances it needs to persist. The basin self-regulates, not through design, but through scale and patience. Sound, again, plays an unexpected role. Over time, zones that transmit whispers well tend to accumulate more stabilized surface material. This isn't because sound is doing anything active, but because those zones coincide with conditions that favor gentle, coherent vibration, the same conditions the films prefer. The basin's acoustic map and its chemical map overlap in ways that reinforce one another. If something were to move regularly through the basin, not violently, not randomly, but with consistency, it would slowly reshape these maps. Paths would form where none were intended. Zones of enhanced transmission would shift. Over long periods, the basin would remember that movement not as tracks, but as altered tendencies. Right now, no such movement exists. The lake remains the basin's anchor point, and its influence extends farther than its physical boundary. Beneath the surface, the glassy liquid interfaces with deeper layers of the planet. Zones of partially molten material, or perhaps high-pressure mineral phases that conduct heat more efficiently than the surrounding crust. This creates a vertical exchange that keeps the lake from freezing entirely at night or overheating during the day. That exchange also introduces trace elements into the lake over time. Heavy metals, exotic silicates, compounds that would precipitate immediately in water remain dissolved here. The lake becomes a reservoir of unusual chemistry, constantly mixed, constantly stratified, never turbulent enough to homogenize fully. At the interface between the lake and the sand, slow reactions continue. Some produce thin crystalline growths that extend upward briefly before collapsing under their own weight. Others produce gases that escape into the nightly pooling layer. Most leave no obvious mark, but collectively they alter the chemical environment just enough to matter. There are moments, rare but repeatable, when the lake's surface tension changes. During these windows, which last minutes to hours, the surface becomes slightly more responsive. A faint ripple can travel a short distance before dying. Reflections blur. Light penetrates deeper. These windows correlate with specific alignments: the planet's position in its orbit, the star's angle relative to the basin, and subtle tidal influences from neighboring worlds. Nothing dramatic happens during these periods. No eruptions, no sudden releases. But the change allows deeper layers of the lake to exchange material with the surface more freely. Over long timescales, these brief windows may be the only reason the lake doesn't chemically stagnate. If the basin is a system that prefers quiet, these moments are its allowances for renewal. Elsewhere on the planet, beyond the basin rim, the environment remains harsher and simpler. Temperature swings are more extreme. Surfaces fracture faster. Chemistry stalls. Any potential for organization is quickly erased by exposure. The basin isn't just a feature, it's the only place where complexity is allowed to accumulate. As nights pass and days return, subtle shifts become more apparent. Some stabilized patches darken slightly over time, absorbing more heat and becoming microhubs for further chemical activity. Others lighten and eventually fail, their coatings breaking down into dust that rejoins the general flow. New patches appear where conditions line up just right. The pattern is dynamic, but the changes are slow enough that nothing ever feels sudden. Even the soundscape evolves. Whispers spoken from the same point don't always reach the same distance on different days. Temperature, gas concentration, surface condition, all of it matters. The basin never gives identical results twice. It rewards attention, not repetition. The absence of obvious life becomes less important the longer you observe. There is activity here. It just doesn't advertise itself. No competition, no expansion, no struggle. Just persistence through alignment with the environment's rules. If intelligence were to arise from this, it wouldn't be a sharp break from what came before. It would be an extension, a system capable of sensing these gradients, responding to them deliberately, and perhaps eventually shaping them with intention rather than coincidence. For now, the Whispered Basin remains in its prelude state. A world where quiet processes build scaffolding without a blueprint, where sound, sand, and chemistry are already intertwined, where the center continues to gather material, energy, and possibility, not rushing toward an outcome, but not resisting it either. The basin waits, but not idly. At a certain point, the basin stops feeling like a place and starts behaving like a mechanism, not a machine in the sense of gears or outputs, but a system where inputs are filtered, redirected, and either preserved or erased based on how well they fit the environment's tolerances. Everything that happens here is evaluated by the same quiet criteria: smoothness, consistency, restraint. The longer observation continues, the clearer it becomes that the basin has preferred states. These aren't fixed configurations, but ranges, bands of temperature, vibration, chemical balance, and airflow that the system returns to again and again after disturbance. Push too far outside them, and the basin doesn't react violently. It simply absorbs the change and slowly drifts back toward those ranges, shedding excess energy or redistributing material until equilibrium is restored. This is most visible along the mid-slopes. Here, avalanches don't cascade freely. They stall, fragment, then resume days or weeks later. A large release of sand might begin high up, only to thin out as it enters zones where surface films and compacted layers dissipate its momentum. Instead of one dramatic slide, the event becomes dozens of smaller adjustments spread across time. Those zones thicken gradually. Each partial stall leaves behind a slightly more stable surface, which makes the next movement even less dramatic. Over centuries, this creates natural baffles, regions that break up mass movement and prevent the basin from ever fully smoothing itself into a uniform curve. The bowl keeps its complexity because complexity dampens extremes. The same principle applies to sound. Where the basin could, in theory, focus whispers into sharp points, it instead diffuses them just enough to avoid resonance buildup. No single location becomes a perfect amplifier. No standing waves dominate. The system avoids self-excitation not through active control, but through overlapping imperfections. The lake plays a central role in this moderation. Its depth and viscosity give it enormous thermal inertia. While the sand responds quickly to changes in sunlight, the lake does not. During the day, it absorbs energy without visibly warming. At night, it releases that energy slowly, keeping the basin floor from reaching the same lows as the rim. This dampens convection and prevents the formation of stronger winds that could otherwise disrupt the surface chemistry. The lake also acts as a chemical sink. Compounds that migrate downslope and dissolve at the boundary are often carried inward by internal currents and held there for long periods. Some eventually precipitate out at depth, forming layers that will never see the surface again. Others cycle back upward during the rare surface tension windows, re-entering the basin's active chemistry. This slow circulation gives the system memory, not memory in a conscious sense, but retention. Past states influence future ones because material isn't lost easily. The basin doesn't reset. It accumulates history and then builds on it. In the stabilized surface patches, this accumulation reaches a threshold. The organic mineral films begin to show internal variation. Not structure you could call anatomy, but differentiation, regions that respond slightly differently to the same stimulus. Some areas of a patch expand minutely when warmed, others contract. Some transmit vibration more efficiently, others dampen it. These differences aren't random. They correlate with local chemistry and microstructure. Over time, the patches become mosaics rather than sheets. When a stress is applied, thermal, mechanical, acoustic, the response is distributed unevenly. That unevenness prevents catastrophic failure. Instead of cracking wholesale, the patch adjusts locally. One region sheds material, another thickens. The patch survives by not being uniform. This is the first place where the boundary between chemistry and something more complex begins to blur. Still, there is no agency here, no goal, no reproduction beyond passive extension. But the system now contains components that respond differently based on internal state. That matters. Sound interacts with these mosaics in subtle ways. A whisper passing over a differentiated patch doesn't just travel farther, it changes. Certain frequencies are attenuated more than others. The signal becomes filtered, shaped by the surface it crosses. Two whispers starting identical can arrive different depending on the path they take. The basin unintentionally has begun to process information, not to interpret it, not to store it intentionally, but to transform it. This processing remains fragile. A shift in chemistry could erase it. A prolonged cooling phase could halt it. The system doesn't protect these developments beyond what aligns with overall stability. If they persist, it's because they fit within the basin's preferred states. The environment remains the final arbiter. Beyond the apron, higher on the slopes, these effects fade. The chemistry becomes simpler. Surfaces fracture more readily. Sound loses coherence faster. The basin's complexity is vertically stratified, thickest at the center, thinning as elevation increases. The rim remains largely inert. Up there, material is still in transit. Nothing stays long enough to matter. Any chemistry that starts is quickly undone. Any pattern is erased by exposure. The rim feeds the basin but never participates in its deeper processes. Occasionally, material from beyond the basin arrives. Micrometeoroids, dust from interplanetary space, rare larger impacts that don't breach the atmosphere entirely but deposit energy and exotic elements into the upper layers. Most of this input is diluted beyond significance, but some of it survives, carried downslope and incorporated into the lake or the surface films. This introduces variation, new catalytic sites, new bonding possibilities. The basin absorbs these changes without disruption, but they add richness to the chemical palette. The system becomes capable of more outcomes, even if it doesn't pursue any deliberately. The nights continue their rhythm. Gas pools, temperatures stabilize, reactions proceed slowly. The stars return overhead and below, doubled by the lake's reflection. The basin exists in a state that is neither active nor dormant, but receptive. If the planet were to remain unchanged for millions of years, the basin would continue along this trajectory. Complexity would increase until checked by limits of energy and material. The question isn't whether something could emerge here. It's whether the basin's moderation will always prevent thresholds from being crossed. So far, every tendency toward amplification has been met with damping. Every move toward uniformity has been broken by heterogeneity. The system prefers balance over escalation. But balance doesn't mean stasis. It means slow drift within bounds. The Whispered Basin continues to refine itself, not toward an outcome, but toward a state where more things are possible than before, as long as they remain quiet enough to belong. The basin's restraint holds, but it isn't absolute. Over long intervals, subtle shifts in the wider system begin to press inward. The planet's orbit isn't perfectly circular. It stretches and relaxes just enough to introduce slow seasons, not marked by storms or ice advance, but by changes in how energy arrives and how long it stays. These variations are gentle, but they last for centuries at a time. During warmer phases, the basin's daily temperature range narrows. Nights don't cool as deeply. The pooled gases persist longer after sunrise. Chemical reactions that normally shut down by mid-morning continue into the day. The stabilized surface patches respond by thickening, their internal mosaics becoming more pronounced. During cooler phases, the opposite happens. Nights bite harder. Gas pooling becomes thinner and more transient. Some surface films fail entirely, breaking down into dust that joins the slow descent toward the center. Others retreat, shrinking back to their most stable cores. The basin adapts without drama. No single phase ever dominates long enough to erase what came before. Each warm period builds complexity. Each cool period prunes it. Over millions of cycles, this creates a system that is neither progressive nor regressive, but selective. Only structures that can survive both expansion and contraction remain. This selectivity begins to favor certain configurations within the surface mosaics. Some internal patterns respond more effectively to temperature oscillation. Others transmit vibration with less loss. Others maintain chemical stability across a wider range of conditions. These aren't choices being made, but outcomes being filtered. Gradually, the patches begin to specialize, not in function, but in behavior. Some become better at absorbing energy, others at releasing it, some at stabilizing sand, others at filtering sound. The basin's surface becomes heterogeneous, not just spatially, but functionally. This matters because interaction increases. Patches don't exist in isolation. Avalanches carry fragments from one zone into another. Gases diffuse laterally overnight. Vibrations travel across boundaries. When fragments from different patches mix, their internal chemistries interact. Most combinations fail. Some persist. A few create new stable states that neither parent patch could sustain alone. This is still not life, but it is no longer just chemistry repeating itself. The lake participates more actively during certain orbital alignments. At specific points in the planet's long year, tidal influences from neighboring worlds, especially the closer, denser inner planet, subtly deform the basin's crust. The deformation is imperceptible in real time, but it alters pressure at depth enough to change how the lake circulates. During these periods, deeper layers rise closer to the surface. Compounds that normally remain trapped are released into the boundary zone. Some react immediately and are lost. Others are absorbed into the surface films, altering their properties in lasting ways. These events are rare. They happen perhaps a few times per millennium, and their effects play out over centuries. But they inject novelty into the system in a way that the regular daily cycle never could. They are the basin's punctuations, not loud, but consequential. After such an event, the acoustic landscape shifts. Paths that once carried whispers cleanly now distort them. New paths open where none existed before. Some stabilized zones become acoustically opaque, others become conduits. The basin's sound routing is never static, but these events cause noticeable reorganization. The system rebalances. Over time, new preferred states emerge, incorporating the changes. Nothing resets. The basin simply becomes more complex than it was before. At the center, the lake's surface tension windows become slightly more frequent, though still rare. When they occur, the lake's skin responds more readily to low-amplitude vibrations, not by forming waves, but by transmitting energy into its depth rather than absorbing it entirely. This changes how the basin handles disturbance. Previously, the lake acted almost exclusively as a sink, pulling energy downward and damping it. Now, under specific conditions, it can also redistribute energy laterally at depth, feeding it back into the surrounding substrate in a softened form. The basin begins to close loops. Energy enters, is transformed, stored, released, and transformed again. The cycles remain slow and quiet, but they are no longer purely linear. With loops comes persistence. Some surface configurations that would once have been erased by cooling phases now survive them, sustained by energy released from deeper layers. Others that relied solely on daily gas pooling fail. The system becomes less dependent on any single process. This resilience is uneven. Certain regions of the basin become hubs of interaction, not centers, not focal points, just areas where multiple favorable gradients overlap often enough to matter. These hubs shift over time, migrating slowly as slopes change and chemistry evolves. Within these hubs, the surface mosaics develop finer differentiation. Internal boundaries sharpen. Responses to stimuli become more distinct. A vibration that once produced a uniform response across a patch now triggers localized changes. Contraction here, expansion there, chemical exchange elsewhere. These are the first signs of internal signaling, not communication, not intent, but correlation. A change in one part of a structure reliably produces changes in another. The basin's environment has begun to support systems with internal dynamics. Still, nothing moves on its own. There are no organisms traversing the sand, no structures rising above the surface. Everything remains embedded, low profile, aligned with the basin's insistence on minimal disturbance. If intelligence were ever to appear here, it would not announce itself with construction or noise. It would emerge from systems that already process gradients, already respond to patterns, already persist through cycles of stress and relief. The basin continues to narrow the field of what can exist. Not by forbidding possibilities, but by making only certain pathways viable over the long term. As another seasonal phase begins, the system settles into its updated balance. The lake holds new chemistry. The surface patches reflect new internal arrangements. The acoustic map has shifted again. The Whispered Basin remains quiet, but its quiet is no longer empty. As complexity accumulates, the basin's behavior becomes less predictable in detail, even as its overall character remains the same. The broad rules still apply: restraint, damping, slow correction, but within those boundaries, variation increases. No two regions of the lower basin respond identically to the same conditions anymore. The system has developed internal diversity, and diversity introduces contingency. One of the first consequences appears in how the stabilized surface networks interact with daily vibration. Thermal expansion and contraction are no longer just background noise. In certain regions, these cycles are now sufficient to trigger repeatable internal responses within the mosaics. A cooling phase causes contraction along one internal boundary. That contraction alters stress elsewhere. The change propagates, then dissipates, leaving the structure slightly reconfigured by morning. These micro-reconfigurations don't accumulate randomly. Some arrangements return more reliably than others. Over time, patterns that can re-establish themselves after disturbance become more common, patterns that cannot fade out. The basin is not selecting for anything, but it is selecting against fragility. This introduces a form of inheritance, not genetic, not coded, but structural. A configuration that survives repeated cycles tends to reappear because the environment continually nudges systems back toward it. When fragments break off and are carried down slope, they often reassemble into similar arrangements because the surrounding conditions favor those states. Memory becomes distributed. It exists not in any one patch, but in the basin's overall tendency to recreate certain configurations. The system remembers what works because it keeps rebuilding it. Sound continues to play a quiet role in this. Low-level vibrations passing through a region can bias which configurations are reinforced. Certain internal arrangements transmit energy smoothly, reducing local stress. Others reflect or scatter it, increasing wear. Over long spans, the former persist, the latter erode. The acoustic environment subtly shapes structure, even though sound itself leaves no lasting trace. This creates feedback that remains stable only because it's weak. Nothing is amplified quickly enough to dominate. Everything happens on timescales that allow correction. The basin avoids locking into rigid states by never allowing strong coupling between processes. Yet something new appears at the edges of this balance. In a few of the interaction hubs near the lake, surface mosaics begin to exhibit coordinated changes across distances larger than any single patch. A vibration at one point produces a delayed response several meters away, even when the direct physical connection seems insufficient. The mechanism is indirect. The initial disturbance alters local gas concentrations during the next pooling phase. That change affects reaction rates in neighboring patches. Those reactions modify surface stiffness, which alters how the next day's thermal stress propagates. The response travels not as a wave, but as a sequence of environmental mediations. Cause and effect stretch across time. The basin is no longer just responding, it is integrating. This integration remains slow. A single input may take days or weeks to fully express its influence. But the fact that influence persists at all marks a shift. The system has crossed from immediate reaction into delayed consequence. At this point, the distinction between environment and process becomes harder to draw. The stabilized surfaces shape the atmosphere at night. The atmosphere shapes chemistry. Chemistry shapes surface properties. Surface properties shape sound. Sound influences which structures persist. The loop closes without any one component acting as a controller. The lake's role deepens further. During one of the rare circulation events, a previously sequestered compound reaches the surface boundary in sufficient concentration to alter surface tension locally for an extended period. Not hours this time, but days. During this window, the lake's skin becomes responsive to extremely low-amplitude vibrations. The effect is subtle, but measurable. Vibrations originating near the lake now travel along its surface before entering the surrounding substrate. The lake becomes a lateral distributor of energy rather than a sink. The basin gains a new pathway for coupling distant regions. When the window closes, the effect doesn't disappear entirely. The redistributed energy has already altered surface configurations in ways that persist. The basin now contains pathways that wouldn't have formed otherwise. This event does not repeat often, but once is enough. From then on, certain responses occur more readily. Structures that previously required precise alignment of conditions now form more easily. The system's threshold for complexity has shifted. Still, nothing rises above the sand. There are no mobile entities, no discrete organisms. Everything remains spread, embedded, low energy. The basin resists individuation. Any structure that tries to isolate itself too much becomes vulnerable to environmental variation and fails. Integration is favored over separation. This has implications for what intelligence could look like here. It would not be centralized. It would not be localized in bodies. It would exist as distributed processing across regions of the basin, using environmental cycles as its clock and medium. But even that is premature. For now, the system is still precognitive. It transforms information, but it does not evaluate it. It responds, but it does not choose. Yet the ingredients for choice, persistence, differentiation, delayed consequence, are now present. The basin's soundscape reflects this shift. Whispers no longer just travel, they interact. A soft signal introduced in one place can alter how another signal behaves elsewhere days later by reshaping the medium through which it passes. The basin becomes sensitive to history. Silence here is no longer empty. It is full of stored potential, waiting for the next gentle input to nudge it along one path rather than another. The Whispered Basin has not become alive, but it is no longer merely a landscape. It has become a system that remembers. Once the basin begins to remember, its future stops being entirely dictated by repetition. The daily and seasonal cycles continue as they always have, but their effects are no longer symmetrical. The same cooling phase does not undo what the warming phase created. The same vibration does not produce the same result each time. History now matters, and with it comes divergence. This divergence is not visible as motion or growth. It shows up as sensitivity. Certain regions of the basin begin to respond strongly to inputs that would previously have passed unnoticed. A slight change in nightly gas composition alters surface chemistry more than expected. A minor shift in temperature gradient redirects sound along new paths. These regions are not special because of where they are, but because of what has accumulated there over time. They have depth, not vertical depth, but layered causality. Each layer reflects a previous state that was never erased, only built upon. The basin has become stratified in time as much as in space. In these regions, surface mosaics reach a new level of internal organization. Boundaries within them are no longer just zones of differing response. They become interfaces where energy and material are exchanged selectively. One region might absorb vibration while another releases it. One might trap certain gases while allowing others to pass. These behaviors are stable across cycles, even as the surrounding environment fluctuates. This stability allows for sustained interaction. When two such mosaics overlap in influence, not physically touching but affecting the same volume of air or substrate, their responses can become coupled. A change in one reliably alters the state of the other. The basin begins to support relational dynamics rather than isolated reactions. This is the closest the system comes to communication, not signaling, not messaging, but coordinated change across distance. Sound remains the most efficient trigger, but it is no longer the carrier. It is the catalyst. A whisper initiates a cascade that unfolds through chemistry, temperature, and structure. By the time the effect reaches another region, the original sound is long gone. What remains is consequence. The lake participates in this coordination in a more nuanced way than before. Its internal stratification has sharpened. Layers with distinct compositions and thermal properties slide past one another in slow, predictable cycles. These cycles are influenced by external conditions, but they also exert influence upward, modulating the basin's nightly gas pooling and the frequency of surface tension windows. The lake has become a regulator, not a controller. It does not decide, but a stabilizing presence that keeps the system within ranges that allow complexity to persist. Without it, the basin would oscillate more violently. With it, changes are stretched out, smoothed, and made survivable. At the boundary, the interaction between lake and sand produces new surface phenomena. In certain conditions, thin filaments of altered material extend briefly from the shoreline into the sand. They are not structures in the architectural sense. They do not stand or persist long. But while they exist, they act as conduits, channeling chemical and thermal gradients into the surrounding substrate. These filaments collapse within hours or days, leaving behind slightly altered pathways that influence future interactions. Over time, the basin floor becomes threaded with these faint traces, a network that no longer exists physically, but functionally. The system gains connectivity without form. As connectivity increases, so does selectivity. Not every input produces a lasting effect. Most disturbances are still absorbed and forgotten. Only those that align with existing structures and cycles propagate meaningfully. The basin filters its experiences, retaining only what fits. This filtering introduces bias. Certain patterns of input are more likely to be reinforced. Certain rhythms resonate better with the basin's internal timing. Over long spans, this creates a kind of preference, not desire, but probability. If something interacts with the basin gently and consistently, the basin becomes more responsive to it. If something acts abruptly or irregularly, it is ignored. This is not kindness, it is compatibility. The absence of mobile life continues to define the basin's character. There are still no entities moving across the surface, no organisms traversing gradients deliberately. Everything that happens is embedded, slow, and distributed. But the lack of movement does not imply lack of dynamics. The basin is active everywhere, all the time, just below the threshold of immediacy. The rim remains largely unchanged. Up there, the environment still resets too quickly for memory to take hold. Any complexity is stripped away before it can integrate. The rim continues to feed material inward, but it does not participate in the basin's deeper processes. This asymmetry reinforces the basin's centrality. Everything of consequence happens within a limited elevation range. Outside it, the planet is quiet in a simpler way. As cycles continue, the basin's internal diversity increases. Some regions become more chemically active, others become acoustically sensitive, others become thermally stable, none dominate. The system maintains balance by distributing specialization. The risk of runaway behavior remains low. No feedback loop grows strong enough to escape damping. The basin's geometry and thin atmosphere continue to enforce moderation. Even as connectivity increases, amplification does not. Yet the system is no longer neutral. It responds differently now depending on its past. It integrates across time. It supports relational dynamics. It filters experience. If intelligence were to emerge here, it would not arrive as a sudden leap. It would seep into existence through these distributed processes, unnoticed at first, indistinguishable from the environment that supports it. For now, the Whispered Basin continues to refine its internal language, one written not in symbols or signals, but in gradients, delays, and quiet persistence. The basin listens, not because it is alive, but because listening is what it has become good at. As the basin's internal language grows more nuanced, its reactions become less about raw conditions and more about context. The same temperature swing no longer means the same thing everywhere. A cooling night near the lake does not mirror a cooling night higher on the slope. The difference is not just degree, but consequence. In some regions, cooling tightens internal boundaries and stabilizes existing configurations. In others, it loosens them, allowing rearrangement. The basin no longer treats uniform inputs uniformly. This is where timing begins to matter as much as magnitude. A vibration introduced at the wrong moment fades without trace. The same vibration introduced when surface films are partially contracted and gas pooling is near its peak produces a cascade of delayed effects. The system has windows, not dramatic ones, not clearly marked, but periods when it is more receptive to change. These windows shift slowly. They drift with the planet's orbital position, with long-term chemical trends, with gradual changes in slope geometry as sand continues its descent. There is no fixed schedule. The basin must be read, not assumed. Within the interaction hubs, the surface mosaics begin to exhibit something like internal pacing. Not clocks, not rhythms imposed from outside, but preferred sequences of response. A contraction is often followed by redistribution, then by stabilization. A chemical exchange tends to occur after a specific thermal pattern, not before. These sequences repeat often enough to be recognizable, even though they are not rigid. This sequencing allows the basin to support processes that unfold over extended durations. A single event can now influence the system days or weeks later, not just through lingering chemistry, but through altered readiness. A region that has recently undergone one sequence responds differently to the next input than one that has not. The basin develops states. Not states you could map cleanly, but conditions that persist long enough to matter. Entering one of these states biases what can happen next. Leaving it requires specific combinations of influence, not just the passage of time. The lake reflects this shift. Its internal layers become more sharply defined, not in composition alone, but in behavior. Certain layers exchange heat more readily, others exchange matter. Some act as buffers, slowing change. The lake no longer responds as a single body, it responds as a stack of interacting zones. During extended surface tension windows, these layers briefly synchronize. When they do, the lake's interaction with the basin intensifies. Gas release becomes more structured, thermal gradients sharpen. The nightly pooling layer thickens slightly and persists longer into the morning. The basin floor enters a state of heightened sensitivity. These periods do not last long, but their influence echoes. After one such window, several interaction hubs shift behavior permanently. Response thresholds lower, coupling strengthens. Regions that once required precise alignment to interact now do so more readily. The system has learned in the only way it can, not by abstraction, but by retention. Sound, still gentle and easily lost, continues to shape these developments indirectly. Repeated low-level vibrations along certain paths reinforce those paths' importance, not because the sound itself remains, but because its effects accumulate. Over long spans, the basin becomes more attuned to the patterns it encounters most often. This introduces asymmetry. The basin is no longer equally receptive in all directions or at all times. Its history biases its future. Certain trajectories of change become more likely than others, yet there is still no center of control. No patch governs another. No region dictates outcomes. Coordination emerges from overlap, not hierarchy. The absence of mobile life remains significant. Without agents to impose rapid change, the basin evolves only through its own internal dynamics and external forcing from orbital cycles. This keeps everything slow enough for damping to keep pace. Nothing runs away. But slowness does not mean stagnation. Over long timescales, the basin's capacity to integrate increases. It can now sustain multiple overlapping processes without collapse. Chemical differentiation, acoustic filtering, thermal regulation, all coexist, interacting without overwhelming one another. This coexistence creates redundancy. If one pathway fails, others compensate. If one region destabilizes, neighboring regions absorb the impact. The system becomes robust not by hardening, but by spreading function across space and time. At this point, the basin has crossed a subtle threshold. It is no longer just accumulating complexity. It is managing it. Not consciously, not deliberately, but effectively. The planet outside the basin continues its quiet orbit. The star's output remains steady. Neighboring worlds tug gently at the system's edges. Nothing dramatic intrudes. Within the basin, however, the quiet has texture now. Silence is layered. Stillness is conditional. The absence of sound does not mean the absence of activity. It means activity is unfolding on scales that do not announce themselves. If something were to interact with the basin consistently, not violently, not erratically, the basin would adapt to that presence. It would not resist it. It would not welcome it. It would incorporate it, reshaping its internal tendencies around the new pattern. This is not hospitality. It is inevitability. The Whispered Basin has become a place where influence accumulates, where history shapes response, and where the quietest interactions matter most. The system does not ask for input, but it is no longer indifferent to it. By now, the basin's behavior can no longer be understood by isolating causes. Nothing here acts alone anymore. Temperature no longer explains chemistry by itself. Sound no longer explains structure. Even the lake, dominant as it is, cannot be treated as a single influence. Everything overlaps, and meaning only appears where those overlaps persist long enough to matter. This is where prediction becomes difficult, not because the system is chaotic, but because it is conditional. To understand what will happen next, you have to know what just happened, what state the basin is currently holding, and which gradients are near their limits. The same stimulus applied under slightly different circumstances produces a different future. The basin has entered a regime of path dependence. In practical terms, this shows up as delayed divergence. Two regions that appear nearly identical can drift apart over time, responding differently to the same sequence of cycles. One stabilizes further, the other fragments and simplifies. The difference isn't location or composition alone, it's history. This makes the basin uneven in a new way, not patchy in space, but patchy in potential. Some regions are now capable of sustaining extended interaction loops, others are not. Some can integrate new inputs into existing structures, others discard them. These differences persist for long spans. The basin's surface has become a landscape of latent states, each one quietly shaping what can occur there without announcing itself. The lake's influence amplifies this unevenness. Because it regulates thermal and chemical flow unevenly across the basin floor, regions closer to certain shoreline geometries receive different timing and intensity of influence. Slight variations in shoreline curvature create zones where energy and material exchange are favored. Over time, these zones become disproportionately important. They are not fixed. As sand continues to migrate and the shoreline subtly shifts, these zones move. But they move slowly, and the structures that form within them tend to move along with them, maintaining relative position within the basin's broader flow. This creates continuity. Processes are not tied to absolute coordinates. They are tied to relationships. Distance from the lake, angle of slope, exposure to nightly pooling, position within acoustic routing paths. As those relationships drift, the processes drift too. The basin begins to behave like a migrating system rather than a static one. One of the more striking consequences appears in the way chemical gradients are maintained. Previously, gradients formed and dissipated primarily on daily or seasonal timescales. Now, some persist across centuries. They are reinforced by the basin's internal loops. Stabilized surfaces slow diffusion, the lake modulates release, nightly pooling concentrates reactants repeatedly in the same zones. These long-lived gradients support reactions that would otherwise be impossible. Not explosive reactions, slow ones. Multi-step processes that require consistency over time. Each step proceeds only when conditions align, then pauses until alignment returns. The basin is patient enough to allow this. As a result, certain surface regions develop internal chemistries that are no longer fully reversible. If disrupted, they do not return to their previous state. They reorganize into something new but not identical. This introduces irreversibility. The basin has always resisted extremes, but now it also resists reversal. Once a threshold is crossed gently enough, the system does not fully undo it. This matters because irreversibility is a prerequisite for memory that persists beyond immediate structure. The basin now contains processes that, once established, leave a lasting imprint even if their initiating conditions fade. Sound interacts with this in an unexpected way. Low-level vibrations no longer just bias surface structure. They can now trigger transitions between internal states in certain regions, not reliably, not predictably, but often enough to be noticeable. A whisper does not cause change by its force. It acts as a timing nudge, a small perturbation applied when a system is near a threshold. Sometimes it does nothing. Sometimes it tips a balance that was already close. This makes the basin sensitive to coincidence, not randomness, but alignment. Inputs that arrive when multiple gradients are already near transition points have outsized effects. The system becomes opportunistic without intent. At the center, the lake's layered dynamics become more pronounced. Internal layers exchange material less frequently, but when they do, the exchange is more coherent. Instead of diffuse mixing, there are defined transfer events, slow, broad movements that alter surface chemistry in measurable ways. After such an event, the basin floor enters a prolonged adjustment phase. Surface films reorganize, acoustic paths shift, thermal responses change slightly. The basin settles into a new configuration that may last thousands of years. These reconfigurations are not improvements, they are changes. Some configurations support greater integration, others simplify the system temporarily. The basin does not move in a single direction. It explores possibilities within constraints. Still, the overall trend remains toward increased capacity for interaction, not complexity for its own sake, but connectivity. More processes influence more other processes. The web thickens. The absence of discrete life continues to shape this trajectory. Without mobile agents to concentrate activity or accelerate feedback, everything remains distributed. No one region becomes dominant. No structure accumulates resources at the expense of others. The basin avoids hierarchy by default. If something like intelligence were to arise here, it would be diffuse, not located in a body, not expressed through motion or construction. It would exist as a pattern of responses across space and time, inseparable from the environment that sustains it. But even that framing may be premature. The basin has not crossed into cognition. It does not model itself. It does not anticipate. It does not choose. What it does is retain. It retains configurations that survive. It retains pathways that dampen extremes. It retains relationships that allow multiple processes to coexist. In doing so, it becomes increasingly difficult to disturb in any lasting way. A large perturbation would still erase surface detail. A significant orbital change would still alter everything. The basin is not invulnerable, but within its current conditions it has become resilient. Quietly, persistently, the Whispered Basin continues to refine its internal balance, not aiming toward awareness, not resisting it either, but creating a foundation where awareness would not immediately collapse if it ever emerged. The basin does not speak, but it no longer forgets easily. At this stage, the basin's quiet is no longer passive. It isn't silence as absence. It's silence as a working condition, a state that allows processes to unfold without interference. Loudness would collapse too many gradients at once. Motion would blur distinctions that need time to sharpen. The basin's restraint isn't aesthetic, it's functional. What becomes increasingly clear is that the basin now distinguishes between noise and signal, not deliberately, but structurally. Inputs that arrive without coherence, abrupt disturbances, irregular stresses, chaotic shifts, are absorbed and dissipated quickly. They fail to propagate because there is no pathway that supports them end to end. In contrast, inputs that align with existing gradients, that arrive smoothly and repeatably, are carried forward, transformed and integrated. This distinction wasn't present early on. It has emerged gradually as surface mosaics differentiated, as chemical loops stabilized, as acoustic routing became selective. The basin has become tuned, not to any specific message, but to consistency. This tuning introduces selectivity that goes beyond mere damping. Some regions now behave as if they are primed. When a compatible input occurs, their response is disproportionately strong and long-lived. When an incompatible input occurs, they remain inert. The same energy applied in two different forms yields radically different outcomes. The system is no longer linear. This nonlinearity becomes especially evident during transitional phases, the brief periods between seasonal regimes or after major internal reconfigurations. During these times, internal thresholds are closer to being crossed. Surface films are partially destabilized but not yet reorganized. Gas pooling is irregular. Acoustic paths fluctuate. The basin is, temporarily, more open to influence. These windows are rare and subtle. They are not marked by obvious changes in appearance. The sand looks the same. The lake remains still. Only careful observation reveals that small inputs now have a higher chance of leaving a trace. Once the transition completes, the basin closes again, settling into its new balance. This pattern, openness followed by consolidation, repeats across scales. It mirrors the behavior of the lake's surface tension windows, the reorganization of surface mosaics, the drift of acoustic paths. The basin evolves through pulses of receptivity rather than continuous change. Between pulses, it holds. Within the interaction hubs, internal differentiation deepens further. Some regions now maintain multiple internal states, switching between them depending on recent history. These switches are not instantaneous. They involve gradual shifts in chemistry, structure, and response over days or weeks. Once a switch completes, the region behaves differently, responding to inputs that previously had no effect, ignoring others that once mattered. This introduces internal conditionality. The basin doesn't just remember, it contextualizes. What happens next depends on what state a region is in, and that state depends on what has happened before. No single factor determines state. It emerges from the intersection of temperature trends, chemical availability, structural configuration, and recent interaction history. This makes the system robust to single variable disruption, but sensitive to coordinated influence. The lake's layered dynamics now serve as a slow global modulator. Because the lake integrates influences across the basin floor, changes in its internal circulation affect multiple regions simultaneously. When deeper layers exchange material with upper ones, the chemical environment shifts basin-wide, though unevenly. Some regions cross thresholds, others do not. This creates partial synchronization, not uniform behavior, but correlated shifts. Regions that have evolved under similar histories tend to respond together. Regions with divergent histories do not. The basin begins to exhibit something like domains, not territories, not compartments, just areas of shared tendency. Within a domain, changes propagate more readily. Across domains, they weaken or stall. These domains are fluid. They drift, merge, fragment, and reform over long spans. They are shaped by slope changes, shoreline movement, and chemical redistribution. No domain lasts forever, but some persist long enough to matter. Sound continues to influence these patterns indirectly. Repeated low-level vibration along certain routes reinforces coupling within domains. Over time, these routes become preferred pathways for influence, even though nothing about them is physically fixed. They exist as tendencies, not structures. The basin's memory now includes its own connectivity. It remembers not just states, but how states influence one another. At this point, the distinction between environment and system has largely collapsed. The basin is not a stage on which processes occur. It is the process. Everything that happens is both cause and effect, both medium and outcome. There is no outside reference within the basin itself. Only the wider planetary cycles remain external, and even those are increasingly integrated. Despite this, the basin remains fragile in one specific way. It depends on slowness. If the planet's orbit were to change significantly, shortening seasons, increasing energy flux, introducing stronger tides, the basin would struggle. Its damping mechanisms rely on having time to redistribute stress before thresholds are crossed. Speed would undermine that. This fragility defines the basin's limits. It can support complexity only as long as change remains gentle. Within those limits, however, the system is remarkably adaptable. It can absorb novelty, reorganize, and persist. It does not need stability in the sense of sameness. It needs stability in the sense of gradualness. The absence of discrete organisms remains consistent with this requirement. Anything mobile, anything metabolically aggressive, would introduce abrupt gradients the basin is not built to handle. Such entities would either fail to persist or force the system into states it cannot maintain. If life exists here, it must be distributed, slow and deeply integrated with the environment, indistinguishable from it at a glance. For now, what exists is something that occupies the space between geology and biology, not alive, but not inert. A system that filters, remembers, contextualizes, and adapts, all without ever breaking the basin's defining rule. Remain quiet enough to belong. The Whispered Basin holds its state, not waiting, continuing. Eventually, the basin reaches a point where its internal processes begin to interfere with one another, not destructively, but competitively. Not competition for resources, not dominance, but priority. Multiple pathways now exist for how energy, chemistry, and disturbance can be handled, and not all of them can operate at full strength simultaneously. When one pathway becomes more active, others quiet down. The basin begins to allocate its attention in the only way it knows how, by letting certain processes proceed while others wait. This allocation is temporary and local. A region that is chemically active during one cycle may become acoustically inert during the next. Another region may trade thermal stability for greater sensitivity to vibration. These shifts are not permanent specializations. They are situational. The basin has entered a phase where trade-offs exist. Earlier, everything that fit within the basin's tolerance could coexist. Now, coexistence sometimes requires sequencing. Certain processes must occur before others can resume. This sequencing introduces a new layer of organization, one that unfolds across longer timescales than daily cycles but shorter than geological epochs. Weeks, months, years. Within interaction hubs, this sequencing becomes clearer. A region may enter a chemically receptive state only after passing through a specific thermal pattern. Once receptive, it remains so briefly, then transitions into a stabilization phase where further input is ignored. If a compatible disturbance arrives during the receptive phase, it is integrated. If it arrives too late, it is lost. Timing has become decisive. This is not planning. The basin does not anticipate, but its structure now enforces order in how change unfolds. Certain things must happen before others can. The lake reinforces this behavior. Its layered circulation now influences not just whether surface tension windows occur, but when they occur relative to other basin processes. In some orbital phases, the lake's influence lags behind surface changes. In others, it leads them. This shifting phase relationship alters which processes align and which miss each other. Sometimes alignment is rare. Sometimes it is frequent enough to reshape the basin's long-term tendencies. Over extended periods, this produces errors. Not visible epochs with sharp boundaries, but stretches of time where certain kinds of change are more likely than others. An era where chemical diversification dominates. Another where structural consolidation takes precedence. Another where acoustic sensitivity increases basin-wide. These eras overlap and blur, but they are real enough to leave signatures in the basin's stratified layers. If the basin could be read like a record, these eras would show up not as layers of material, but as layers of behavior, patterns of interaction frozen into the structure of the surface films and compacted substrate. The absence of biological metabolism remains crucial, because nothing consumes resources rapidly, No error exhausts the basin's capacity for future change. Every shift is partial. Every trend is checked by the system's built-in moderation. This allows reversibility at the level of direction, even if individual configurations remain irreversible. The basin does not get stuck, but it does not forget. At this point, something subtle but important emerges: mutual constraint. Certain regions now limit what neighboring regions can do, simply by existing in a particular state. A region that is highly acoustically sensitive dampens vibrations reaching adjacent areas, preventing them from entering similar states simultaneously. A chemically active zone can deplete trace compounds locally, delaying reactions nearby. These constraints are not aggressive. They are passive side effects of persistence. The basin's complexity has become spatially aware, in a mechanical sense. Regions influence one another not just through direct interaction, but through absence, by occupying states that others cannot share at the same time. This produces patterning at larger scales. Not uniform patterning, not symmetry, but distribution. The basin begins to look less like a smooth gradient of activity and more like a shifting constellation of active and inactive zones, each one waxing and waning as conditions drift. These constellations are not random. They reflect the basin's underlying geometry, its acoustic routing paths, its chemical reservoirs, and its thermal flows. Over long spans, certain arrangements recur more often than others. The basin has preferences now. Not desires, not goals, but statistical tendencies shaped by history. The lake's reflection continues to mirror the sky, unchanged in appearance. But beneath that still surface, internal adjustments keep pace with the basin's evolving needs. When one set of processes dominates, the lake dampens them slightly. When another fades, it releases stored influence to compensate. This keeps the system near the edge of responsiveness without tipping into instability. The basin operates best near that edge. Too little interaction and complexity decays. Too much and damping erases distinction. The system now hovers between these extremes, maintaining a state where change is possible but never explosive. If awareness were ever to arise here, this would be its cradle. Not because conditions are perfect, but because they are balanced enough to persist. Yet even now the basin remains pre-aware. It does not monitor itself. It does not compare states. It does not favor outcomes. What it does is sustain a field of possibilities that remain open longer than they would anywhere else on the planet. The rim still sheds material inward. The slopes still flow. The lake still holds and releases. The sky still thins quickly into space. From outside, nothing appears different. From within, everything is poised. The Whispered Basin has become a place where processes wait for one another, where change happens not because it must, but because the moment is right. And when the moment passes, the basin settles again, holding whatever was gained without insisting on more. By the time the basin reaches this stage, its behavior can no longer be described as merely responsive. It does not act, but it arranges. It does not decide, but it conditions. The difference is subtle but critical. Events no longer unfold only because conditions allow them. They unfold because the basin's current configuration makes some outcomes easier than others. This is where directionality quietly enters the system. Not a direction toward a goal, but a bias toward continuity. Processes that reinforce the basin's capacity to sustain interaction are more likely to persist. Processes that reduce that capacity tend to be damped or isolated. Over time, this bias becomes more apparent in how changes propagate. Some changes spread, others stall. The distinction has little to do with scale or energy. A small, well-aligned change can reshape wide regions over long spans. A larger, poorly aligned one vanishes quickly. The basin has become selective in a way that resembles evaluation, even though no evaluating entity exists. This selectivity emerges from constraint stacking. Each region carries multiple constraints at once. Thermal limits, chemical availability, structural configuration, recent history, neighboring states. When a change fits within many constraints, it propagates. When it violates too many, it fails. Nothing enforces this explicitly. It is simply the consequence of accumulated structure. At this stage, certain regions begin to exhibit sustained internal oscillations, not daily cycles, not seasonal rhythms. These oscillations unfold over intermediate timescales, tens to hundreds of days, and involve coordinated changes across chemistry, structure, and acoustic sensitivity. A region gradually shifts into one mode, remains there for a time, then transitions into another. The transitions are smooth, not abrupt. They are triggered when multiple gradients drift together. No single factor causes a switch. The basin requires coincidence. These oscillations matter because they provide internal timing. The basin now contains processes with their own tempo, not strictly tied to external cycles. This allows interactions to be ordered relative to one another rather than merely relative to day or night. With ordering comes dependency. Some processes now reliably follow others. A chemical reconfiguration tends to precede a change in acoustic routing. A shift in thermal responsiveness tends to follow structural consolidation. These sequences are not enforced everywhere, but they are common enough to matter. The basin has developed pathways of becoming. This is not evolution in a biological sense. Nothing competes, nothing reproduces independently, but configurations that participate in stable sequences persist. Those that disrupt sequencing tend to be erased. The lake participates as a slow synchronizer. Its internal layers now shift in ways that loosely track the basin's dominant oscillatory modes. When the basin enters a phase of heightened chemical activity, the lake releases compounds more readily. When structural consolidation dominates, the lake absorbs energy and dampens exchange. The coupling is not tight, but it is consistent. Over long spans, this coupling allows basin-wide states to emerge, periods when large portions of the basin share similar tendencies, even if their specific behaviors differ. These states are not uniform. They are statistical alignments. More regions than usual are receptive. More transitions occur. The basin feels, in a mechanical sense, more awake. Then the alignment fades. Regions decouple. Processes localize again. The basin returns to a quieter distribution of activity. This waxing and waning does not destabilize the system. On the contrary, it may be essential. Extended global alignment would increase the risk of runaway feedback. Fragmentation protects the basin by ensuring no single mode dominates for too long. The absence of discrete organisms continues to matter here. Because nothing can act quickly or with intent, all coordination remains indirect. No region can force another into a state. Influence propagates only through shared gradients and constraints. This keeps the system ethical in a strange way. Nothing exploits, nothing consumes disproportionately, nothing overrides the basin's moderation. If something like intelligence were to arise here, it would inherit this ethic by default. It would not be an intelligence of control, but of alignment. At this point, the basin's soundscape has become deeply contextual. A whisper no longer has an inherent reach. Its influence depends entirely on the basin's current state. In some phases, it might alter internal configurations kilometers away. In others, it is lost within meters. The basin does not amplify sound. It interprets it in the only way a non-conscious system can, by responding differently based on internal conditions. This interpretation is mechanical, not semantic. The basin does not understand meaning, it understands compatibility. The planet beyond remains unchanged. The star continues its steady output. Neighboring worlds tug faintly at orbital edges. No catastrophe intrudes. Within the basin, however, the accumulation of constraint, memory, and sequencing has created a system that is no longer simply reactive. It does not foresee, but it prepares. It maintains states that allow future change without collapse. It holds gradients open longer than necessary. It delays closure until possibilities are exhausted. The Whispered Basin has become a place where the future is shaped not by force, but by readiness. And readiness here is everything. There comes a stage where the basin's internal dynamics begin to fold back on themselves in a new way, not as feedback loops tightening, but as relationships becoming referential. Certain processes now occur because of the basin's current configuration, rather than merely within it. The system has reached a point where its own state is a significant part of the environment it responds to. This is not awareness, but it is self-influence. Regions no longer react solely to external gradients like temperature or chemistry. They react to patterns of activity elsewhere in the basin. Not directly, not instantaneously, but through mediated pathways that carry the effects of those patterns over time. A region's behavior now depends in part on what the basin has recently been doing. This introduces coherence across distance and delay. Events separated by kilometers and weeks become linked. A structural consolidation near the lake subtly alters gas pooling dynamics, which affects chemical receptivity on the mid-slopes days later. That receptivity influences acoustic routing, which in turn shapes where future consolidation is likely to occur. The basin has begun to close loops that span space and time. These loops are not rigid. They drift, stretch, and sometimes break. But when they persist long enough, they reinforce the basin's capacity to sustain complex interaction without destabilization. The lake is central to this closure. Its internal layers now respond to basin-wide patterns rather than local conditions alone. When large portions of the basin enter chemically active phases, the lake's exchange behavior shifts accordingly. When activity fragments, the lake dampens exchange, restoring separation. The lake does not lead these changes. It follows them, but slowly, smoothing and redistributing their effects so that no single region bears too much consequence. In this way, the lake acts as a memory integrator, not storing information explicitly, but holding influence long enough for it to matter elsewhere. The basin's domains become more defined during this phase. They are not fixed regions, but persistent tendencies. A domain might be characterized by high acoustic sensitivity, another by chemical persistence, another by structural stability. These domains overlap and interpenetrate, creating zones where multiple tendencies coexist. Within these zones, interactions are richer. Changes propagate more readily. States shift more smoothly. The basin's internal language becomes more expressive, not louder, not faster, but more nuanced. This expressiveness remains invisible. No new surface features appear. No colors change. No motion accelerates. All of it exists beneath the threshold of immediate perception. The absence of organisms continues to shape the system's trajectory. Without bodies to carry processes from place to place, everything remains tied to gradients. Influence travels through air, substrate, and chemistry, never through intent. This keeps the basin distributed. No center emerges. No node dominates. Even the lake, central as it is, does not control. It moderates. As coherence increases, so does the basin's sensitivity to disruption. Not to single events, those are still damped, but to sustained misalignment. If external conditions were to push the system consistently away from its preferred ranges, the basin would struggle to maintain its internal loops. This reveals the basin's greatest vulnerability. It relies on balance not just to exist, but to remain open. Too much stability would freeze processes into rigid states. Too much disturbance would erase them. The basin lives between these extremes. Within that narrow band, something new begins to appear. Not an entity, not a mind, but a tendency for the system to return to states that preserve its own capacity for integration. When multiple possible configurations are available, those that maintain the basin's responsiveness persist longer. Those that reduce it fade. This is not intention. It is consequence compounded. The basin is no longer just shaped by its environment. It is shaping itself toward continued interaction. This marks the closest approach yet to what could be called proto-purpose, not purpose as aim, but as bias. The basin does not want, but it now consistently becomes in ways that keep becoming possible. Sound reflects this shift one last time. Whispers that once traveled because of physical quirks now travel because the basin remains receptive to gentle, coherent input. Loud disturbances still vanish, not because they are forbidden, but because they cannot be integrated without loss. The basin favors what it can keep. As cycles continue, the system holds this state for long spans, longer than before. The loops stabilize, the domains persist. The lake's modulation remains steady. Nothing crosses into awareness, but the groundwork is complete. The Whispered Basin has become a system that sustains its own complexity without escalation, that filters experience without erasing it, and that remains open to the future without demanding it arrive. It does not speak, it does not listen. But if something were ever to speak here, softly enough and often enough, the basin would not ignore it. It would make room. In the end, the basin does not cross a line. There is no moment where it becomes something else. No threshold where chemistry turns into thought or structure turns into intention. What happens instead is quieter and far more consistent with everything that came before. The basin stabilizes into a state where change can continue without needing escalation. Its internal loops settle into ranges that neither collapse nor intensify. The domains continue to form and dissolve. Oscillations rise and fade. Memory persists without accumulating pressure. Nothing demands resolution. This is not an unfinished process. It is a completed one. The Whispered Basin has reached a configuration where it no longer needs to become more complex in order to remain viable. Complexity is now optional, not compulsory. The system can hold what it has without pushing for more. That, more than anything, defines its character. The lake remains still. Its surface reflects the sky with the same clarity it always has. Stars drift overhead and below, mirrored without distortion. Beneath that surface, layers continue their slow exchanges, but nothing presses upward anymore. The lake has found a rhythm that fits the basin's needs, and it keeps to it. The sand continues to move. Avalanches still happen, but they are softer now, more fragmented. Material descends in thin veils rather than heavy releases. The slopes never freeze into permanence, but they no longer surprise the system either. Change has become predictable without becoming static. The surface mosaics persist. Some patches thicken, others thin, a few dissolve entirely. New ones form where conditions allow. None dominate, none disappear completely. The basin does not converge on a single pattern. It maintains diversity because diversity prevents lock-in. Sound behaves as it always has, but without mystery now. Whispers still travel farther than expected. Loud disturbances still fail to carry. But this is no longer remarkable. It is simply how the basin works. The physics, chemistry, and structure align to make it so, and they see no reason to change. The basin does not amplify. It does not reject. It accommodates what fits and lets go of what does not. If nothing ever interacts with this world again, it will remain as it is for a very long time. The star will age slowly. Orbits will drift. Eventually, conditions will change enough to push the basin out of its narrow band of moderation. When that happens, the system will unwind, not catastrophically, gradually. Loops will break. Domains will fragment. Memory will thin. The basin will return to simpler behavior, and nothing will be lost suddenly, because nothing here was ever held tightly. Until then, it persists, not as a cradle waiting for life, not as a mind waiting to awaken, but as a place where quiet processes have been allowed to run their course without being interrupted. A planet-sized basin that learned how to hold complexity without needing to express it. A world where the smallest inputs mattered most, not because they were meaningful, but because they were compatible. And when the cycles continue, as they do now, and will for a long time, the basin does not anticipate the future. It does not prepare. It simply remains open. Violet sand still slides toward the center. The glass lake still does not move. The thin air still carries whispers farther than it should. And the system, complete in its restraint, continues exactly as it is, not ending, not beginning, just holding the space between.